Hello everyone, this is Alex Dunn. We're going to be talking about the Flux architecture and design pattern in Xamarin. We're going to go over what Flux is, why use it over other design patterns. We're going to look at using Flux in an actual implementation with Xamarin, and then we're going to go ahead and build an app together from scratch. So some assumptions about this presentation. You should have some knowledge of building apps with Xamarin. It shouldn't be new to you. You should have some familiarity with Xamarin.Forms, since the app we're going to build is going to be written in Xamarin.Forms. Familiarity with XAML as well as MVVM and two-way binding, since we're also going to be adding that on top of our Flux design pattern. Some resources for you to look at before you start or to tag along with. There's some code up on GitHub I put up of an actual implementation, essentially what we're going to be writing today. There's also some links to Facebook's official documentation on Flux, as well as their demos and examples with React.js. So, what is Flux? It's a client-side application architecture and design pattern built by Facebook. It's used for building robust data-driven user interfaces, and its focus is on the flow of data as well as separation of concerns. So what's different from other patterns is that it's a unidirectional data flow, and it was originally built for React.js, which is Facebook's JavaScript library that they use and are implementing more and more in their actual applications. So if any of you are familiar with React.js, we're going to talk about kind of comparing those parts and moving them into a C# and Xamarin implementation so that when you move from a Flux and React.js situation, it's not so confusing and it kind of makes sense. So the component render function in React.js is basically the same as your actual XAML or C# pager view. The state of a component is what we're going to be using as our view model for the back end of our views. The props of a component is the same thing as passing properties into your views. And then the component lifecycle is going to be compared to our page lifecycle as well as the two-way bindings on our pages. So the basic structure of the Flux architecture breaks it into what are four essential parts. There are actions, the single dispatcher, stores, and views. So an action does some small business logic like mapping input data to a model and then communicates that data to a dispatcher. The dispatcher takes that data and dispatches it to the subscribed stores. The store takes the message, updates whatever data it needs, and then emits those changes down to views that are set to observe changes in the store. Then the view takes that data, updates its state, and then updates the actual UI itself. So a little more advanced of a structure or a realistic implementation is that it's the same thing as we just looked at, but the views can then also call back to actions, which will then, again, tie right back to the dispatcher. So you can kind of see that unidirectional flow of data from an action to the dispatcher to the store back down to the view. Then if something is going to be started again, it's going to be from a user interaction on the view, which will go right back to an action. So here's that structure adjusted for Xamarin on top of MVVM. So our action talks to the dispatcher, updates through the store, but rather than having the view subscribe to the store, we're going to have a view model on top of the view. And that's going to take the data from the store and update its bindable properties, which are bound to the view through our two-way MVVM bindings. So the view is automatically going to update from those binding changes, and then the view is going to take in a user interaction, but rather than sending it right to an action, it's going to fire a command through to our view model, and that command is going to fire an action, which again cycles back to the dispatcher, and it all starts over again. So that's Flux. But why use it, or why is it special? How is it better than doing something with MVC and MVVM or any bidirectional data flow? So some of the problems with those patterns is that there's no restrictions on where the data goes. So it allows for multiple controllers to talk to each other and pass data back and forth. The data is passed frequently so that when you get into a robust solution, that can be hard to manage sometimes. It's hard to track where data is going. It's hard to track what views are sending said data to said controllers and what's coming back down. And there's really loose rules that end up leading to drastically different implementations in these kind of quasi-standards like the Cocoa MVC versus ASP.NET MVC implementation versus Ruby on Rails MVC, which isn't too different from ASP.NET's implementation, but still. So the solutions that Flux brings is that it cleans up that data flow. It pushes it in a single direction. Then it takes that flow and it enables trickle down into your views. So it allows for views to listen to changes from multiple stores. It allows multiple stores to listen to the same dispatched events, and it allows for multiple views to invoke the same action. So there's less restriction in the actual logic that a view can invoke, but it's easier to track where data is coming from because it's all going to sit at that center store. So that's that data has that single point of the stores. It's also great because it can live alongside some other design patterns like MVVM, and it plays well with other project architectures, which we can talk about later, such as domain-driven design, onion architecture, and with inversion of control and dependency injection. So some of those complex data flows we talked about, if you have an action, you could have two stores listen to the dispatched event. So those two stores are going to update two different sets of data, and then you can have multiple views listen to those stores. So you can see view 1 is listening to store 1, and so when an update comes to store 1, it's going to update the UI. But at the same time, view 2 will as well. But then when store 2 updates, view 2 is going to update something else, as well as view 3 updating. And from the other side, with a view invoking multiple actions, the single view invokes two different actions, which updates two different stores, which then, as you can see, kind of bind to whatever number of views you want. And this can scale any way you want it to. But the great part is that you know where the data is coming from because it's based on that kind of domain that your store lives on top of. So let's talk about doing Xamarin.Forms with Flux, MVVM, and inversion of control and dependency injection. So again, there's a resource link here to the GitHub repository where what's essentially what we're going to write is going to live. So the project structure that we're going to look at, it's a basic Xamarin.Forms XAML PCL template. We're not going to build out multiple libraries in an actual like onion architecture or anything like that. We're just going to use our single PCL and build our views, our view models, our entire Flux setup, as well as set up our inversion of control. So you can see with these expanded, the Flux specific components are those actions. So you see the to-do action types, which are kind of the identifiers for the events for the dispatcher. The to-do store, and then the messaging center built into Xamarin.Forms is what we're actually going to use as our dispatcher. If you're not using Xamarin.Forms and you still want to do it, it's not too hard to build a pub sub mechanism like the messaging center. And now that Xamarin.Forms is open source, you could actually just go and take down the messaging center itself. So the MVVM specific components are obviously our view and view model. And then our inversion of control and dependency injection, we have an IOC config, which is going to register dependencies, and also a view model locator. Again, these are just other patterns that can play well with Flux. You obviously don't have to use these either. All the other files that you see are basically just trying to keep things abstracted and clean in the code base and reusable. So the app we're going to build is like any kind of intro app, our typical to-do list. So you're going to see an empty list, the ability to create. We're going to put a populate button in there just so it's easier to create a whole bunch of them. You can view an item afterwards and manage it, toggling it to true when it's complete. You can edit the name of it. You can view larger amounts of data and toggle those individually. You can delete a single line of data. You can complete all items and then delete all those completed items from your list. And you'll be able to toggle all your items between true and false. So let's get started with some code. We'll head over to Visual Studio and build this thing from scratch. Now let's head over to Visual Studio and get our solution started. We're going to open up with a blank XAML app with a PCL. We're going to be creating that to-do list. So let's just get this started. So while that spins up, what we're going to do is create our initial view with just some basic MVVM so we know it's working, and then we're going to take that implementation and kind of fluxify it. So we're going to move the logic out of just like our view model and test data, and we're going to move it into our action store and implement the whole flow of data with Flux. All right, now that we've got our solution finally created, let's get started by clearing out the stuff it starts with. So let's go ahead and delete that starter page. Well, let's add some of the NuGet references we're going to need. The two that we're going to be adding are MVVM Lite. That's just my preference for setting up my MVVM bindings. You can use whatever implementation or other library you'd like. But I've never gone wrong with MVVM Lite. And on top of that, we're also going to add in the user dialogues plugin, just for simplicity's sake. It'll allow us to do things like send alerts, toasts, or prompts while in the view model or anywhere in the PCL really from a singleton. So it's just convenient. So we don't have to build pages for creating a to-do item or editing one. We can just do it right in the dialog from our single page. For the sake of the demo, I'm just going to run this in iOS, but you'd also want to add your user dialogues in all of your client apps, or really all of your specific NuGet packages. But because we're just running it in iOS, I'm only going to add it here. Once this is done, we're going to go build our list page. So why don't we head over here, set up our folders for our view models and our views. So now let's go into our view and add a new XAML page. We'll just call it to-do list page. So we're going to need to add some toolbar items, then our list view and those context actions on the list view items. So let's go ahead and type this all out. I'm going to make our populate button. For the short namesake, we'll call it pop. And we're going to want to wire a command up to what will be in our view model. So we're just going to do this ahead of time. And then for the sake of speed, I'm going to copy and paste for the other three. We have our toolbar items. Let's just add our list view as the content for the page. So we're going to work around what some people consider a bug, but is really just a difference in our implementation with those context actions. So I'm going to give this a name just so that we can reference it in our. So I gave that a name just so we can reference it from our context actions, so we can bind commands up to the view model rather than the actual individual item in the list. And we're going to need to bind our item source to some property we'll eventually create called items. Now let's add our item template, which we're just going to use a text cell. We're going to give those their bindings. Oops. I'm going to use a string format here for the is complete, just for speed's sake. Now to add our context actions. So we're going to need a delete, toggle, and an edit. So let's add each menu item. This one, is destructive true. So this is where I was talking about we have to kind of set up our binding a little interestingly. So we're going to make a reference to our to-do list view, and then the path to it is going to be the binding context and then another command. So this is the delete command for a single item. And then the command parameter sent up is going to be bound to the actual to-do item that's going to be bound as the binding context for the actual individual cell. So we're going to do that period there. Oops. All right, now let's do some more copy and pasting to get our toggle and our edit. These are not destructive, so we're just going to clear it out because it's the default. Cool. Now let's change these commands, our individual toggle command, and then our edit command. And that's it. That's our entire view for our application. All right, now let's go define our model for our actual to-do item. So we'll make another folder here for models. Oh, keep missing my O there. And we're going to add a to-do. So in order to make our changes propagate to our view automatically, this model also has to implement iNotifyPropertyChange. So we're going to set that up to use our shortcut from MVVM Lite, their viewModel base class. So we're going to define our private properties for, say, an ID, the text, and our isCompleted. And then we're going to set up our public actual bound properties to handle the iNotifyPropertyChange. So this is that shortcut from MVVM Lite if you haven't seen it before. I'm going to do that for these other two as well. Scroll down so you can actually see it down there. There's our model. Cool. So now let's go to our actual view model for our page. We'll go create that. Call this our to-do list page view model. Now this is also going to inherit that view model base. So first thing we need is, to properly set this up. I don't know what those shortcuts were doing there. Not what we wanted. So let's set up our actual item source. We're going to have an observable collection of to-dos. We'll call that items. Bring in collections, the object model, and we're going to need to bring in the namespace for our model itself. Let's also make the private fields for those commands. So we're going to need a create command, bring in this Windows input namespace. We're going to need a toggle command for toggling a single one. The toggle all command, delete command, if I can spell it, delete all, the edit, and our little shortcut populate. Populate. Struggling. Cool. So those are all our private fields. Now let's implement our actual iNotify property change to our bindable public properties. And let's set up our commands here. So we're going to want our public create command. We're going to use that null check there and then set it. I'm going to use a relay command, which is also part of MVVM Lite. You can also use the built-in Xamarin.Forms command here if you'd like. I'm going to actually fill in the content here once we actually wire up each of the commands themselves. So we'll leave that empty for now. Nope, not the toggle all, just the regular toggle, thank you. And this is going to actually take in a to-do item there. We're going to need to set up the generic here. So that expects a to-do. We'll just keep working down the list. All right, now we have them all of our commands emptied. We can go in now and actually implement each of them. So here we're going to actually make this async because we're going to use one of the user dialog interfaces. Bring in our user dialog namespace, get the instance, and then we're going to want to prompt async. So for create, we're going to use the simple overload. No message, and to give it a title of new, we'll say done, cancel, and then we'll give it a placeholder of to do. So we need to actually assign this to a response. There we go. And if the result is okay, then we are going to add a new item, new to do, give it an ID of a random GUID. Oops. The text is going to be the result text there, and is complete is going to be false. Cool. There we go. Now in our toggle command, we're going to want to go find the existing item, where the ID matches. I guess in this case we can just set the item. Oops. So now in the toggle, all we're going to do is set the is complete to the opposite. So that should automatically propagate. And in here, we're going to use that user dialogs method again. So we're going to need to make this async. Get the singleton, prompt them. Except this time we're going to actually use the config so we can preset the value to the existing value. So we can use their fluid API, set the text to the to-do's existing text, set the title to edit, set the OK text to done, set the cancel text to cancel, oops. And we're going to set a placeholder. Cool. Oop, not set cancelable. Set cancel text. Cool. Now again, we'll check if it's okay. And then we will change the text of our to-do item passed in to whatever the result text is, and that will propagate through our observable collection. Toggling all, we're going to find out if all of them are complete. So we're just going to do an any check here. Are all complete against our items? Should say if items. There are not any where it is complete. And we're going to loop over each of them, and then set the is complete flag to the opposite of are all complete. Then from delete, we're just going to remove it. Oops, items, remove to do. Easy peasy. And for the delete completed, we're going to get all the ones that are complete. Using our link extensions. Then for each one, I really should to list this so we don't have an issue with changing. Oops, also this should be completed items. We're going to list this just to handle that removing from an enumerable while enumerating. So then we're going to call items.remove item. And then in populate, we're just going to create a random one and add it. So let's just go for like 20 or something. So we'll actually make a for loop. Less than 21, I++. And we'll add a new to-do. This use our shortcut here. New item is completely false. Cool. Oops, missed my parentheses. So now let's create our constructor for the view model just to set our observable collection. And that'll do it. So now let's go back to the code behind for our to-do list page. And then in the constructor, we're just going to set the binding context for the entire page to equal a new instance of our to-do list page view model. All right. Didn't bring my namespace in. Now that we set our binding context, the last step to do is to just go into our app XAML and set our main page. We're going to use a new navigation page just so we get the items onto the toolbar items. And we're going to wrap our to-do list page. Didn't bring it in. There we go. Now let's run that on our simulator. When we run it, we can see we have our empty list with our toolbar items. We can go ahead and populate it. We can take an item and delete it. We can edit an item. We can create a new one. See it down at the bottom of the list. We can toggle a whole bunch of these and then clear the toggled ones. We can toggle them all. We can populate a whole bunch of them. So now that we have our working list and page and all that, let's now go and Fluxify it. We're going to add our actions, our action types for our IDs for our events, our stores, and then we're going to use that dispatcher to send stuff around. So over in Visual Studio, I've added these to-do action types, which are just these constants that define the names of the actions that are going to be invoked. So over in the Solution Explorer, we've also added this action section, which is going to have an empty interface for iActions. We'll open that up. And our to-do actions. So we have the interface there so that the Xamarin.Forms messaging center has a base type to send around as the sender so that multiple stores can take from multiple different actions without having to explicitly set each one. And so now in these actions, we can go ahead and set up our actions such as add to do, which will take in the text, and then we'll talk to the messaging center in Xamarin.Forms, and we'll send that message as an iActions, and obviously the type is going to be string since that's our text we're going to send over. So this is our sender. The message type is going to be of those action types, to-do action types, add to-do, and the arg is going to be the text that we send over. So now we'll just go ahead and fill out the rest of these methods here with each of the different actions. So now you can see we have actions for deleting all completed, deleting an individual, editing a to-do, toggling a to-do, and toggling all of them. And they call the messaging center and send the appropriate data down for the stores to consume. So now let's take a look at the stores. We've set up this base store, which is going to wrap a bit of the subscribing and emitting to the messaging center and down to the views that are subscribed to it. So our subscribe is going to just take in an event type and then call the messaging center.subscribe to whatever the event type is, and then we're going to call our base implementation of receive event. Each individual store is actually going to implement this differently by switching over the different event types that it's trying to subscribe to or that it expects and needs to change data from, and then is going to afterwards emit the data down to the views that are subscribed to it. So that's why we have our public event handler up here for onemitted, and we have a custom store events args, which is really just the string for the event type that each of the views is going to expect. So now let's head over to our to-do store and actually implement the logic that's going to go on. So here's our empty class. We're going to want to inherit the base store, and our base data type is going to be an observable collection of to-dos. So now in our constructor, we can tell the store which events it wants to subscribe to from the dispatcher. So we can call subscribe. This is going to expect a string for add. So now we're going to call to-do action types dot add. We're also going to want to subscribe to each of these other events. So now we've set up our subscription. Let's go ahead and make sure that our data is initialized to a new observable collection. So now if we take a look at our base store at that receive event, this is what's going to be called each time one of the messages from the dispatcher is received. So you can see we're set up to either send down null or send down whatever the actual type of data is that's passed in. So what we're going to do in our to-do store is override that on event received, or sorry, receive event. Come on, there it is. And we're going to want to call the base last because the base is what's going to actually emit the data. You can go ahead and simplify that. So now let's add a switch to the event type. And then for each one of these event types, we're going to want to do some custom logic. So let's say for add to do, action to do, oh my gosh, do action types dot add. We're going to want to actually add a new item to our data set. Not sure why it added the namespace there for no reason. So we're going to set a new GUID. Text is going to be the data passed as a string. And is completed is going to be false. So now we'll go through each of these different events and add the individual logic that it needs to update the data accordingly. So now that we've handled each of the cases for our different event types we're expecting, you can take a look at on completed all or delete completed. We're going to find the ones that are completed and remove them the same way we did in our view model. For the delete, we're going to find it and remove it. For edit, we're going to find it by its ID and then set the text to the new text. For toggle all, we're just going to find where they are all complete and then flip them. And then for toggle, we're going to find it by its ID and then switch the flag there. So that's all there really is to our to-do store. We're subscribing to our different events from our dispatcher, and then we're handling receiving them and then emitting them down to the view. So the last thing we need to do now is update our view model to change out that logic and set it to actually call actions and handle events coming in from our store. So what we're going to do is go to our view model. We're going to add some private read-only actions and stores. Oops. Read-only to-do actions. Looks like it didn't bring in my namespace there. Cool. So now these are going to get passed in through the constructor. We'll set that up at the very end with the glue for all of our different, with setting up our IOC container. This is going to expect a to-do store and to-do actions. Now what we're also going to do is actually subscribe to the store itself. So we're going to take our to-do store and we're going to add an event handler to our onEmitted. I'm going to change that ugly name. Cool. So from here we can also switch on each of the event types the same way we did in the store. But for the sake of this demo, this isn't actually going to update anything in the UI since all that's still going to happen through our two-way MVVM binding. But for the sake of demonstrating how that would be done, what we're going to do is use our user dialogues plugin and then call to show a toast when an action happens. So let's handle our switch case here for to-do action types. Bring in the namespace of add. And we're going to call user dialogues, instance, and then toast item added. And then we'll go ahead and do that for each of our different events that are going to be emitted. Okay, so you can see for each emitted event, we're going to be calling a toast to tell you basically what action was actually completed and brought all the way back down to the view. So now let's change our commands around as well as our data. Since our data is going to be coming from the store, we can actually skip having our own observable collection field and have this just return the to-do store's data. We're going to need to delete the item from our constructor as well. So now for each one of these commands, rather than actually calling to affect the data, what we're going to do is call directly to an action. So for populate, we'll add a to-do. And this is just going to take the string, so we don't even have to do the initialization anymore. And then we can clear all this out. For the delete completed, we'll just call the appropriate action and clear that out. For delete individual, we'll pass in the ID of the to-do, and then that'll trickle down. And we'll run those kind of updates for each of these commands. So there we go. Our create command's updated. Each of our actions is updated to just call into the action. So now rather than just updating this single view's data, we're going to end up updating the data in the store, which then multiple views could listen to changes to. So now the last bit to do, now that everything's kind of been fluxified, is actually tie in our IOC and our view model locator to actually send in our store and action into the constructor of our view model and kind of handle things cleanly. So what we're going to do is add an IOC config class and a view model locator. So here's our tiny little IOC config, and all this is doing is setting up using simple IOC, which is packaged with MVVM Lite, and it's just going to register our action stores and view models so that they can be automatically sent into each other's constructors. So the last thing to do now is add a view model locator so that we can auto bind that binding context right within the XAML. So here's our view model locator. We only have the one view model to locate, but this is also what's going to actually kick off our IOC container creation and configuration. So this is going to happen automatically when we set up our bindings into our view. So this is going to get created the very first time it's called, and that's what's going to automatically set up these different registrations within our IOC container. So all we have to do now is actually go update our app XAML to add a resource to our view model locator, and then we're going to update our to-do list page XAML to actually automatically create the binding context. So you can see in our app XAML what we did was add a resource dictionary to our application resources, and this is just going to have a reference to our view model locator, which is going to then be able to be passed through a static resource down to our page. So now let's head over to our page. And you can see that the binding context is now set to automatically pull from that locator source. So now if we run this, we should be able to see the same results. So here we are running our fluxified version of our app. And you can see it's going to function just about the same way, except now you can see when we populate, we had that little toast at the bottom. You can see it again if we create a new item. See, our little item added toast. Now we can go ahead and toggle them. The item was toggled. We can clear toggled ones, items deleted. We can edit a given one. which we didn't have an event actually set up to send a toast. We can delete that individual one. We can toggle all of them. And we can delete the toggled ones, which in this case is all of them. So it's pretty cool. So from here, what you can do is you can go ahead and add any number of pages you want that can also subscribe to that to-do store the same way that the to-do list view model does. And then when something updates here, those views are going to automatically update, including sub-views or content views. It doesn't just have to be a complete page. Anything that's a view can listen to the store updates. So even if you have, say, like a complete custom render or a full page that needs to be written in native and not in Xamarin.Forms, what you can do is have those individual views and pages subscribe to the same stores that your Xamarin.Forms pages do, and those can be wired up to update automatically as well. So that'll just about do it. That's using the Flux architecture and design pattern within Xamarin, specifically with Xamarin.Forms on top of MVVM and inversion of control. So thanks for watching, and keep an eye out for more videos to come.